How do you find quartiles when even or odd number of data elements are given to you? I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll discuss measures of dispersion using ungrouped data. There are 4 questions which we'll discuss in this particular video. The question here is, for each set of data, find the lower quartile, median, upper quartile, and interquartile range. As you can see, the 4 questions are for n equals to 9, that means odd number of data elements, n equals to 11, another set of odd number of data elements, and then n equals to 8 and 10. So then it becomes even number of data elements. Well, the formulae which are used for finding quartiles position are different for odd and even. So we'll try to see how are they different and how should we work along with them. Well, you can always pause the video and answer these questions. My idea is to make you understand the complete concept. First, we'll find the quartile position, and from the position, we'll find the quartile's value. Once we have the value of all the 3 quartiles, then we'll find interquartile range as the difference between Q3 and Q1. So as you know, IQR is basically equal to third quartile minus the first. So let's begin with these solutions. Here are a few definitions which we should understand before getting in details. We have been talking about measures of dispersion, that is basically range is one way and the other way is interquartile range, which we calculate using quartiles. Now range fails many times since it does not represent the data correctly if we have some outliers or exceptionally low or high values. Perfect. So in that case, interquartile range is a better parameter since it is looking into the bulk which is right there in the middle, avoiding those which are at the far ends, right? So this box and whisker diagram gives you the interquartile range which is between Q3 and Q1, which is bulk of the data, right? So range is the difference between the largest and the smallest value. It is affected by the outliers. 3 quartiles divide data in 4 equal parts. So exactly 4 equal parts, 25% data in each. Lowest and the highest datum are extreme values. So these are the extreme values, correct? Interquartile range, IQR, is measure of dispersion of the middle half of the values. IQR is not affected by extreme values. And as you know, IQR is basically equal to Q3 minus Q1, right? Outliers. Outliers are the data values that are far from the normal. They can be considered abnormal or exceptional. Technically, outliers are 1.5 times IQR away from Q1. This is on the lower side, or 1.5 times IQR away from Q3 on the upper end. Clear? So somewhere here, right? Those outliers. Let's also look into the formula. It is important to understand that these formulas given only provide position of quartiles, right? So only the position of quartile is being provided. So if you have odd number of elements like 7, 9, 11, 13 and so on, then the quartile's position is given by these set of formulas, where basically n1, n plus 1, if the data elements are 11, add 1 to it, divide by 2. So 6th element is right there in the middle, right? sixth element will be right there in the middle. So 5 and 5 on each side, correct? So you get the median. Now, leaving aside this median, on both the sides, we have, like in 11, we'll have 5 and 5. The middle values will give us lower quartile and the upper quartile. So the formula for them is n plus 1 quarter, 1/4, and third quartile will be 3/4 of n plus 1. So all these are straightforward. For median, it is half of n plus 1, and for Q1, 1/4, and Q3 is 3 times Q1, correct? Now, when the data elements are even, then definitely the middle value is average of 2, right? And therefore, the modified formulas are here. Well, you will see that Q median for Q2, the position is exactly same, which is n plus 1 divided by 2, right? But it's different for Q1 and Q3. Now, for making it simple for you to remember the formula, I've slightly modified and written it in a very interesting way. So see, I'm writing Q1 is n plus 2 divided by 4, n plus 2, right? Here I'm writing 2n plus 2. Do you see that? So plus 2 by 4 is common. So, but it is 2n plus 4, 2 divided by 4. And in this case, it becomes 3n plus 2 divided by 4. Do you see that? So n plus 2 divided by 4, 2n plus 2 divided by 4, or 3n plus 2 divided by 4, right? 2n plus 2 divided by 4 is same as n plus 1 divided by 2, right? So these two are exactly same, right? Perfect. So they only give you position. At each position, you have to read the value of quartile. Okay, so let's begin with solving the questions one by one. The very first one is to find lower quartile, middle, upper, and interquartile. So let us begin with always the position for median. That is better, right? So median is n plus 1 divided by 2. So in this case, number of elements 1, 10, 12, 15, 16, 20, 22, 23, 27. These are the elements, 9 of them, right? So here we have n as equal to 9 as given to us. So position we can find using the formula. So median n plus 1 divided by 2. So use this formula, find the position and then read the value, right? So for example, the median will be 9 plus 1 divided by 2, which is 10 by 2 or 5. So fifth position. So 1, 2, 3, 4, 5. Fifth position is 16. So 16 becomes Q2. You understand? So likewise, find the value of each quartile. Correct? So then you match your answer with mine. Well, in case you want to learn from me, you can always send an email on the address given. Most of my students are doing extremely well. Some are right there on top of their class getting awards and scholarships.
After attending university. The winner of this year's Certificate of Achievement Schulich Leader Award is Akshi Kandivani.
Great. Our student Akshat gets highest marks and the most prestigious Schulich Leader Award. You can be there. Join our classes and excel. Let's move on with the solutions of these questions one by one. Right. So the very first one, as I was saying, we need to find lower quartile, median, upper quartile, and interquartile range for the 9 elements given to you: 1, 10, 12, 15, 16, 20, 22, 23, 27. All are actually arranged in increasing order. If they are not arranged, you need to arrange them in increasing order. Make a note of this, right? So arrange in increasing order. Now for these exercises, I have already done that for you. Now, number of elements is 9, correct? So the formula, let's begin with Q2, the center one. So Q2 is always n plus 1 divided by 2, the middle value, right? So in our case, the middle value will be what? We are looking for position, right? N plus 1, n is 9. So this is the position. And so n plus 1 is 10. So we are looking at fifth position. So fifth value. So what is the fifth value of Q2? Let's read it. 1, 2, 3, 4, 5. So it is this number 16. So 16 becomes Q2. Is that clear to you? Perfect. Now let's find Q1. Now Q1 is the middle value of the remaining on the left hand side. So if you see, on the left hand side we have 4 of them. So what do you expect? You expect a value which is between 10 and 12, right? Clear? So that is Q1. So let's find using the formula. So formula is not necessary. You can actually visualize. Okay. So we're looking for position, right? So using the formula, we are only looking at position, not the value. So Q1, the position is 9 plus 1 divided by 4, right? So quarter, right? So which is clearly equal to 10 plus 4, 2.5. That means between second and third element. So as we decided, between 10 and 12. So the value is what? So Q, this is the 2.5th position. Do you understand? The value is add them and divide by 2. 10 plus 12 divide by 2. So the value is 11, right? So the value is 11. So there are two different things. Finding position using formula and then the value using the position, right? So quartile position is found first, right? And then use position to find value, right? Now Q3, let us visualize Q3 first, right? We see 1, 2, 3, 4, it is definitely between these two, right? That becomes the middle value. Is that clear to you? Using the formula, how do we get it? Well, it is 3/4 of n plus 1 divided by 2, right? You get the idea, right? So 3/4 of this, right? Q1. So 3 times, right? Or better, right? 3 times n plus 1 divided by 4. You can write like this also, right? But 3 times Q1 value, right? So we get the position which is 30 by 4. N is 9, right? Which is 8.5, right? So Q3 will be 3/4 of n plus 1, right? So which in this case will be 3/4 of 9 plus 1. So 30 divided by 4 is 7.5. So that is the position, right? And the value will be Q3 equals to between 7 and 8. So we'll add 22 and 23 and then divide by 2. That clearly gives us 22.5. Perfect. So we found Q3. So once we have found all the quartiles, then we can find interquartile range. IQR, the interquartile range, is basically Q3 value minus Q1. And that, in this case, is 22.5 minus 16, correct? So that is how you are going to find this particular answer, right? So 22.5 minus 16 is how much? It is 13 by 2, half of 13, or basically 6.5. So IQR is 6.5. Is that clear to you? Perfect. So you see, first we find position, then the value. Let's do the second question, which is right there for you. There are this time 11 data points. 3, 5, 6, 9, 13, 17, 20, 21, 25, 30, and 35. So where n is 11 for you. So in this case, odd number, use these formulae to find the position. So first find quartile position using the formula. Then you find the element, correct? So let's move on and write down the answer. So always begin with Q2. It is better, right? Center value. N plus 1 divide by 2, the center value, right? So n is 11 plus 1 divided by 2. Clearly, 12 divided by 2 is 6. So sixth position, right? So first thing, find position, sixth position. So 1, 2, 3, 4, 5, 6, 17. So the value for Q3 is 17. Now Q1 is to the left, right? You can see there are 1, 2, 3, 4, 5. So the center value is 6 on the left side. And here we have 1, 2, 3, 4, 5. And the center value is 25. So you can easily identify them, right? Using the formula also you can calculate. So let's use the formula for Q1, which is n plus 1 divided by 4. So which is 12 by 4 or 3. So this is the third position, which is 6 for us. So we have Q1 as equal to 6. Is that clear to you? Correct? So Q1 is equal to 6 for us. Perfect. Now let's find Q3. Using formula, Q3 will be equal to 3 over 4 times n plus 1, which is 3 over 4 times n is 11 for us, plus 1, 12. So that gives me ninth position. Do you see that? And the value is Q3, 25, right? At ninth position. That is what it means, right? So now you can find IQR, the interquartile range, which is clearly Q3 minus Q1. So we have 25 minus 6, right? Which is 19. So IQR is 19 in this particular case. Perfect. So that is how simple it is. As you can see, we can visually also get these values without even using the formula. That is what is very important. Well, in case you want to learn from me, you can always send an email on the address given. So let's take up the next example, which is basically based on even number of data elements. So we'll still find the lower quartile, median, upper quartile, and the interquartile range. But we have now 8 elements. So in 8 elements, 1, 2, 3, 1, 2, 3. You see there are 2 in the middle. So the center value has to be in between these 2. And clearly, we have Q2 as equal to 11. Do you see that? Now, once you divide like this, you see that we have 1, 2, 3, 4 on left, 1, 2, 3, 4 on right. And therefore, middle values will be where? Between these 2, right? So we can read the other 2 values also. Q1 is equal to between 4 and 6, which is 5. and Q3, which is between 15 and 16. So it is 15.5. Is that clear to you? So that is what you should be getting. But you can use the formula to get the exact position. Perfect. Now IQR is what? IQR is Q3 minus Q1. So the difference between 15.5 and 5, which is 10.5, will be IQR. So we have actually found all these values without even using the formula. Perfect. But I'll encourage you to use the formula. As you can see, Q2 formula is same. However, for Q1 and Q3, we are slightly different. N plus 2 divided by 4 and 3n plus 2 divided by 4. Perfect. So let's use the formula and then figure out the answer, right? So for Q2, the formula is same. We are trying to find the position, right? Q2th position. Let me write down to summarize what we are exactly doing. Use the formula, which is n plus 1 divided by 2. Number of elements being 8. 8 plus 1 divided by 2 is 9 over 2, which is 4.5. That means the element between 4 and 5. 1, 2, 3, 4 and 5. So between 10 and 12, correct? So we get our answer that Q2 is basically equal to average of 10 and 12. Add them, divide by 2, that gives you 11, right? So we get Q2 as 11. Now we can work on Q1, first Q1th position, right? Formula is n plus 2 by 4, right? Since we did not really get the value out of it, right? We are remaining with these 4 elements now, right? So n is 8 for us. So 8 plus 2 by 4, which is 10 divided by 4 is 2.5. So it is now the value between second and third element. You see that? So we get Q1 value as average of 4 and 6, which is 10 divided by 2. The value is 5. Is that clear to you? So we have Q1 as 5. Perfect. Let's find the value for Q3. Q3 is the average of the remaining on that side, right? So we have already found Q2, Q1, and out of these 4, the middle value is Q3, right? Let's calculate position first. So Q3th position will be what? 3n plus 2 divided by 4, right? So in this case, 3 times n is for us 8 plus 2 divided by 4. 24 plus 2 is 26. 26 divided by 4 is 6.5, right? So between 6th and 5th position, that means between, this is your 6th and 7th position, right? So 15 plus 16 average, right? So we get Q3 as average of 15 and 16, which is 15.5. And now we can calculate IQR, correct? IQR is basically equal to Q3 minus Q1, which is 15.5 minus 5 or 10.5. Clear? So we used, even without formula, we had found these values. Do you see that? So I'll encourage you to look into the data and understand the concept. Here is question number 4 for you. Take it as a test question. Number of elements, 10. We need to find median first, middle value, right? So you do 10 plus 1 divided by 2, 11. 11 divided by 2, 5.5. So after 5th element, 1, 2, 3, 4, 5, right? So between 5th and 6th, do you see that? So this is our Q2, right? So Q2 is right there in middle. 13 plus 17 divided by 2 gives us 15. Is that clear to you? Now on the right hand side and on the left hand side, we have the other equal parts, which have to be divided equally. That is the meaning of quartile. So 1, 2, 3, 4, 5 means 6 is right there in the center, right? And here we have 1, 2, 3, 4, 5. 21 is right there in the center. So Q1 is equal to 6 and Q3 is equal to 21. IQR is basically Q3 minus Q1, which is 21 minus 6. Does make sense to you, right? Perfect. So which is how much? 15, right? So 21 minus 6 will be 15. So that becomes IQR. You can use these formulas to find the position and the value. So I'm leaving that for you. Perfect. So I'd like you to do the needful, verify the result which we just got here. Perfect. Well, in case you want to learn from me strategies to answer these questions quickly, as we did for some, you can always send me an email. We'll discuss box and whisker diagrams and standard deviations to complete this chapter on measures of dispersion soon, or follow our videos in this particular playlist to get the complete concept of measures of dispersion. Feel free to write your comments and suggestions. If you like and subscribe to my videos, that'd be great. In case you want to learn from me, send an email or visit our website at the given address. Thanks for your time and all the best.